Hi, in this video lecture, we're going to understand the functioning of this particular code snippet. So let's try to understand what exactly this particular code is doing. So in the first line, we have a file inclusion statement. The next line, we have a macro. The name of the macro is total elements. And inside this, we have a statement which says that size of an array divided by size of array of 0, which is the statement generally used to calculate the number of elements in an array. In the next line, we have an array with some elements initialized, and there are totally 7 elements in that. And in the next part, the main function starts, and in the main function, we have a loop to traverse the elements of an array. So we need to identify the output of this particular program. The options given out here are, it's going to print all the elements of an array. It's going to print 5 elements, excluding the last 2 elements. There won't be any output of this program, or will there be an error? Now, let's try to understand this. So when you look at the options and when you look at this particular code, the first thing which comes to mind is I'm basically using this variable name here in line number 3, whereas the variable is declared in line number 4. So can I refer to a variable before being declared? Right, that's the question. But we need to remember that has defined is handled by the preprocessor, which is this phase where the code is preprocessed before being sent to the compiler. So in preprocessing, what it does is it looks out for this macro name anywhere in the code, and on encountering that macro name, it's going to replace this name with this replacement text. So after the pre-processing, you see that this particular line will not exist. Instead, this statement as it is will be replaced here. So you should not get any error. Let's try to verify this. First, let me try to compile this with GCC, the file name, and then you can just observe we did not get any kind of an error. If you want to observe the preprocessed code, we can use the option -e. This will give me the preprocessed code. Preprocessor will do a file inclusion. We can see the contents of the header file is included. But here you can just observe that the macro is not visible here. Instead, inside the for loop, if you observe the statement, what we had is the replacement of text of the macro that has been placed here. So this is the code which actually goes to the compiler, and we are referring to the variable array, right? After creating of the array, not before that. That is the reason why it is not giving an error. And also, if you just observe, I had mentioned few comments at the last, which is the options, but that has been removed. The comments will also be removed with the preprocessor. So now let's look into what could be the other options, because the last option is ruled out. Now, the next thing, if you just observe carefully, here in the for loop, we are starting with an index value of -1 here. The variable d is starting with -1. Generally, if you see, how do we traverse the elements of an array? We quite often use the variable I. We write I equal to 0, I less than n, I plus plus. But here, if you observe, we are starting with -1, and we are writing less than equal to, we are writing again -2 here, right? Okay. So this might create a confusion that probably doing this is not right. Okay. See, I can start the index from any point to any other point. But as long as the index is within the valid limits, accessing the elements of an array is perfectly valid. In case if the index is out of range, then we cannot determine what will be the output. Now, if you see this as -1, are we accessing the array of -1? The answer is no, because if you observe carefully here, I'm not directly referring d as the index, I'm writing d plus 1. So in case if d is -1, this should be -1 plus 1, it should be 0. And in case if d becomes 0, then it will be 0 plus 1, it will be 1. And if d is 1, 1 plus 1 will be 2. So it's going to be like 0, 1, 2. And again, if you look at this particular section, d is less than or equal to this particular statement, total elements minus 2. So total elements as per the statement and considering the number of elements into the array, It is 7. 7 minus 2 is 5. So what will be the index which will be generated here? So here, first time, my d value will be -1, then 0, then 1, then 2, then 3, then 4, then 5. Okay, so 5 is less than or equal to 7 minus 2, right? So it's going to basically run in this way. So totally how many times? 1, 2, 3, 4, 5, 6, 7, right? So d value will be, okay, from -1 to 5. So if you consider this is what the value of d will be, and the loop is going to repeat for 7 times, right? And then every time you're going to access the elements from index 0, will be accessing the element from index 0, 1, 2, 3, 4, 5, 6. So which is basically all the elements. So you will be thinking that the output should be the option 1. Let's try to verify this and see is option 1 my answer or not. I compiled it and I tried to run this particular program. When I tried to run this program, I did not get any output. The question is why? The problem is why is it that it is not printing any elements? So is there any problem with the value of d being -1? No. Is there a problem with this 7 minus 2 is 5? No. But then where exactly the problem? The problem is the data type of d and the data type of this particular expression. Now, when you observe carefully, what will be the return type of size of operator? Size of operator will always give me the size in number of bytes, and that size is basically of type size underscore t. It will be of type size underscore t. Size underscore t is internally represented as unsigned integer or unsigned log integer, right? Now we had the size of the array, which is considering the size of an integer as 4 byte, 7 into 4, 28. But remember, this is unsigned value. Divide by, again, this section also gave me the size of the first element, which is 4 bytes, which is again an unsigned value. Now, finally, when performing this calculation, we got 28 divided by 4, which is 7, which is unsigned, right? We got 7, which is unsigned. Okay. Now, 7 minus 2 is 5, will be equal to 5, right? But if you just observe this d value, d is signed integer. D is signed integer. So now, if d value, if you treat it as -1, and then if one of the operand is signed, the other operand is unsigned, then what really happens is it's going to perform an implicit conversion. If I say sign, and then you use any arithmetic or relational, and you have unsigned, then what it does is it performs implicit conversion. So it will convert signed value to unsigned. Okay. Now what really happens when you convert the value of d, which is -1, from a signed value to an unsigned? To understand that, let us try to look into binary equivalent of -1. I'm going to assume it's basically a 1 byte value. Now, if I say what is the binary equivalent of 1, we can say that it is 00000001. But what about -1? So we need to perform 2's complement. So in order to perform the 2's complement, first let us try to perform 1's complement, right? And add 1 to it. This is 1's complement, and then if we add 1 to this, this will be the value. Now this particular value, if you treat it as sign, you will get back as -1 because it does the conversion and then it gives us -1. But if the same bit pattern, if I try to view this as unsigned, meaning I'm going to assume all the bits are used to represent data, there is no signed bit. So with just 1 byte information, it's going to be looking as 255, or you can say 0xFF. Got it? So you're actually not comparing this -1 with 5. You're comparing this, okay, 255. In fact, I'm used 1 byte, but for 4 byte, it'll be like 32 ones. Okay, it's quite larger number. So that larger number is compared with this. And is 255 less than or equal to 5? The answer is no, right? So due to that reason, it does not enter into the loop. Okay, now I can overcome this by saying that I don't want this to be unsigned. I'd like to convert it to signed value. I've just converted to signed and I'm trying to run this program, compile it. You got the right answer? Okay, because here D is not getting converted from signed to unsigned because I basically forcibly converted this unsigned value into a signed value. Or what I could actually do out here is this statement, I could just capture it into another variable. I could just capture it into another variable. Okay. What is the data type of n? N is of type signed integer. D is also signed integer. N is also signed integer. Now, if I try to compile, I need to put a semicolon there. I'm getting the right output. Now, if there is a mistake where this is a common mistake, what we might do unintentionally, right? So why is it that there is no assistance given from the compiler? There's a question. Okay. Now, such kind of errors are not syntactical errors, but they are not caught by the compiler. If you want to look into such kind of an errors, we need to look into static code analyzers. And one such static code analyzer is splint, right? Let me just try to first compile this program. And again, you can observe there is no warning or an error. I'd like to use a static code analyzer called as splint, and I would like to run the same program. And here I could see that line number 10, operands of less than have incompatible types. At one side you have integer, the other side you have arbitrary unsigned integer. Clear? We got this. And which is line number 10? I'll just show you the code snippet here. This is my line number 10. This is my line number 10. Got it? Okay. So we can basically take the help of static code analyzers to check out for errors which are generally not caught by the compiler. And then we should be very careful while using the sizeof operator and then mixing that with assign integer values, right? So here the correct answer is no output, and I have explained in detail why is it that way. Clear? I hope the concept is clear. Thank you.